Hello, Mr. Ryan, right?
Yeah.
Okay. So we given a list of words like Eric, rice,
My
Ryan, and a Y. Okay? Just some random words.
right.
Okay.
N-N-A-R-Y is not a word, and my name needs a capital letter, otherwise it's not a word.
Okay.
And so is Eric.
So all these words are in lowercase. If the two words contains the same characters, okay, same characters, and we call it similar. Ryan and Liz are similar, even though Liz has more ends, right? The length is different because they are made
What's
of
nary?
R-Y-A-N.
What's nary?
R-Y-A-N.
What's
No,
nary?
something I made up, okay?
What?
And Eric and Rice, obviously. What do you call it?
Is it like live? I'm trying to.
Yeah.
I remember last time you taught us it, and you gave the examples like listening and listen and silence.
Yes, what do you call it? I
think
forgot.
it's something beginning with A. Antonym, anagram.
Anagram, yes, anagram, yes. Good job, anagram. Anagram, okay? So anagram, how do we compare two strings? S1, S2 is anagram. That a few ways, right? We can say we can counter S1 if it's equals to counter S2, right? Because counter counts the character and the frequency. If they're two counters the same, then it's an anagram. Another way is we sort it, right? We can say return sorted. Sorted S1 if it equals to sorted S2, right? Yeah. For example, Eric, when we sort it, you become CEIR. And this right, we sort it, you become CEIR. Okay? And then they are same, so it's anagram. When we sort it, if the string is length n, then the time complexity is O(n) again. But if we use the counter, the space complexity and time complexity is O(n), okay? So this is in terms of the time complexity, this method is faster than the sorting because O(n) is better than O(n) again, right? And the space complexity, this one is O(n) because we're using the counter, but this one, when we sort it, we don't need to use the additional space, that's O(1), right? So in terms of space usage, the O(n) is worse than O(1), right? When we compare if the two strings are similar, we don't actually compare the frequency. R 1 times, N 1 times, A 1 times, Y 1 times. But this one, N 2 times, A 1 times, R 1 times, Y 1 times, right? Because we only compare this. It uses the characters NRAY, NRAY. Then we say these two words are similar. Even this is 2 times, the N only 1 time here. Make sense? Okay, so given this a list of words, we want to find out the number of pairs of the similar strings. ERIC, RICE. This is one pair. RYAN and NNARY. This is another one. So there are 2 pairs. Right? If we have another one like ECIR, okay, and then how many more pairs do we have? If we have one more string, ECIR, we could have ERIC, ECIR, and RICE, ECIR. Okay? Okay, so the first question, how do we compare if two strings are similar?
So there's different ways, like you can sort alphabetically. So and if it's something like an anagram, it should be identical to each other. So you know, that's a pair. And also one way is kind of like, is it value? Is it something like, what's it called?
Okay, so you mentioned about the sorting, right? So look, these two, because it's different than the anagram.
It's something like enumerate. So you list it, like the values and the things. I think it's enumerate.
Okay, enumerate, yes.
Yeah. And so And so, if they contain the same letters, then they should be the same, even if they has different.
Okay. Different frequencies, okay? So look, this is S1, this is S2. Actually, we can do this. We can use a set, filter out the duplicate characters, right? And then we can sort it, right? Sort it the set, then if it's equal, then it's similar, right? Because when we use the set, we remove the duplicate numbers and we only compare the unique characters. And once we do this set, we can actually use the method that we use to check if the two strings are anagram. So there's actually one more step just to filter out the duplicate numbers, am I right? Duplicate characters. Make sense? Yeah? Okay, so Bruteforce, yeah? Obviously we can Bruteforce. Am I right? So we can Bruteforce. Look, answer equals 0 for if n equals the length of the ARR, right? For I in range n, for j in range I, right? So we are checking now, we need to check this ARR I, the index, yeah? We're looping over the index, ARR I and ARR j. So if these ARR I and ARR j are similar, so we can say if set ARR I, actually we can just directly compare with the set, yeah? Set ARR j, right? Then answer plus equal 1, right? Make sense? That's it, return answer. This is the algorithm, Bruteforce. Time complexity, on square. Here. If the average length is m, okay, so the time complexity will be on squared times m. Look, why is that? Here is n. Here is n. Here we're converting each word. The length will be m, right? To a set that takes on time, on squared times n. Okay.
Yeah.
Makes sense? Easier.
Yeah.
Look at the index. This is index. J is up to index I. Okay?
Yeah.
Because the average rise is a pair, but we don't count the duplicate, which is rise average. We only count once, right? Okay? Okay, so that's why the J index looping up to I. So when I is 0, this loop is skipped. When I is 1, okay? 0, J, we don't have any J. When I is 1, the J up to 0, right? When I is 2, 0, 1, okay? When I is 3, 0, 1, 2. When I is 4, J is 0, 1, 2, 3. Okay, so the index of J is always from 0 up to the index of I. Okay, so this is okay, because this is very straightforward, but we can do better. If I want to come up with a way to uniquely identify, like ID a word by the similarity. If we find out a way to compute the ID, the score, or identity of a word, if two words have the same ID, then they are similar. What could you compute?
We can the amount of letters the same I think it's the amount of letters. Like Eric has 4 letters.
Yeah.
And so does Bryce.
Yeah, but this is also 4 letters. But obviously the ID of these should be different, right?
Yeah, and so I think it should be like the same letters.
Same letters and just same letters. Okay, so we can just do this, right? So if this is S, right? So we can just do this. Set S, right? And then sort it. We sort it and then we just join, right? Join it. So this is the function to compute the ID of each word. If two words have the same ID, then they are similar, right? What's join?
You join it with, and you join it and then put whatever you put in the thingy.
I see. Look at this one, okay? Let's do this using this one. Set. The first operation is set, so it will become NARY, right? This is the unique, right? Remove the one extra N, okay? Sort it. When we sort it, it will become A, N, R, Y. Okay? When we join it, right? And it will become A, N, R, Y. Okay, so this is the idea of that. Okay, so we try another one, say, like Eric and Ryan. Okay? So what do we have? Is there duplicate numbers here? Look, when we okay, so first of all
and 2 vowels.
Yeah, we use the set. So what do we have? E R I C Y A N. Okay, and then we sort it. A C E I N R Y. Am I right? And join. Just put a quote. So this is the idea of everyone. Okay. So we can have counter like A equals counter. And we go through these words. Okay, so this is the thing. Word in ARR. If we have this function and define this ID function, this is the S, return this, right? Return this. X equals IDW. IDW. Answer, okay? Answer equals 0. Answer plus equal AX and then AX plus equal 1. Okay, this is very interesting here. Return A. Look, return answer. These 4, we have 2 pairs, right? Okay, look at this example. We have 2 pairs. Go through this word, ERIC. We calculate its ID, right? ERIC. And ERIC, the ID would be CEIR, okay? CEIR. Answer plus ACIR. There's no entry CEIR in that, so answer plus equals 0. Answer still 0. ACIR plus 1, so CEIR. We have 1 entry here, 1. Okay? Okay, RIC. What's RIC is the ID? CEIR. The same, right? X equals CEIR. Answer plus ACIR equals 1, right? So 1 pair. Because originally we meet Eric before, so answer will be 1 now. Now, CEIR, increment 1, so I need to change this to 2. Okay? RYAN, what's the ID? ANRY, right? Answer plus ANRY, there's nothing here, so 0. But this loop, we need to change it to 1, so ANRY equals 1. Okay, this one, look the same, right? ANRY, right? Plus equals 1. And then put these 2. Put these 2. Okay, so we have 2 pairs. Got it? Yeah?
Yeah.
Look, why this is okay. I show you one example. Okay, so this A, the counter stores the ID, previous number of times of these the same similar string, right? Okay, if this is ERIC here, and this is also ERIC here, if this ERIC here. Okay, so now A ERIC, that's 3 times, right? Now, okay, if I have one more ERIC, how many pairs? I already tell you there are 3 Erics, and I have one more Eric. So how many new pairs can you make the similar strings?
I think in total you have 2. 2 because pairs is 2 and 4 divided by 2 is 2.
4 divided by 2, why?
Because you said pairs. Pairs means 2. And
Yeah.
so...
Okay. Okay, no. Look, this is 1 pair, okay? This is 1 pair.
Yeah, those are 2.
I see. No, I'm saying 1 pair.
Yeah, 1 pair is like 2 or something, like a pair of shoes.
Okay. So,
It's also a yummy fruit.
yes.
A pair of pairs.
Okay, come on. Do you understand this question? There are 3 Erics, and I have one more Eric coming. How many new pairs of the similar string can we get? I have one more Eric. So this Eric can pair with this one, compare with this one, compare with this one. How many pairs? 3. So add it 3 here.
I
Because
understand
add it. Okay, and then Eric, there are 4 Eric now. I have another Eric coming. How many new pairs can we have?
4.
Get 4. Plus this number, right? Look, this is
8.
what it is. Look, answer plus already, and then we increment it. Make sense? Does it make sense now?
Yeah, sort of.
Sort of, yeah. This is ideal. Okay, so which one is simpler? The method, which one is simpler?
That one.
This one, you understand this? The previous one is the Bruteforce. There are n words. How many pairs? Without considering the similarity, there are n apples. How many pairs can you make without considering the sequence? Picking 2 out of n. Look, picking 2 out of n. What's this? Cn2. This is equals n times n minus 1 divided by 2. 4, how many pairs? 4 times 3 divided by 2, that's 6. 4 is 1, 2, 3, 4, right? So you pick 2. 1, 2, 1, 3, 1, 4. 2, 3, 2, 4, 3, 4, right? This is the 6 CN2, picking 2 out of 10, okay? So Bruteforce, the time complexity is CN2, okay? The last method I want to mention is based on this. This is ID, right? The ID function. ID, we use this function to calculate ID. And if it's only lowercase, we can change this ID to a better one. Because the ID is a lowercase character. And we could talk about the ASCII, right? ASCII. The ASCII for the A. ORDA. What do we have? Anybody remember the magic number? The lowercase a and the bigger case a. Do you still remember ASCII? ASCII. American, I don't know, exchange information, something
Is
like
A49 the lowercase?
No, lowercase 65. Uppercase is 97. Right?
Wait, that's lowercase, that's uppercase.
Yeah, okay. And then
You said
okay.
uppercase is 97.
Okay, 0. 0 is 48. Okay?
That's supposed to
And the space.
This is supposed
Okay.
to be 97. This is
Okay.
supposed to be-
You know the key. There's an enter key, right? Enter key. Enter key. This is 13, and then there's a space key. Space. This is 32. Okay. The mapping from the key, like ASCII, and ORD is to calculate this number from the character, and the opposite would be CHR. So if we say CHR 97, you give us a lowercase a. Right? And since it's all lowercase, then we can use this bit mask, ASCII bit mask. So we can think of a big integer, and if this is A this is 0, okay? B then is 1, C is 2, D is 3, E is 4, right? So if it's an integer, right? If it's an integer, binary, remember integer, this is A, this is B, this is C, this is D, this is E, okay? So if we have E, then we set this to 1, okay? If we have this R, we set this to 1. If we have I, we set the I to 1, okay? Simple as that, C set to 1, okay? And then we are transforming the words into a number. That's what we are doing. Okay, so then we can do this. 1 shifter ORD W minus 97, right? And then 4 W in word, but we have to reduce this function, okay? W in word actually in word, okay? Okay, so this is, I'm talking about this word, okay? Word, and then we can use this reduce function, reduce OR like that, okay? So the reduce function basically you're saying that I want to apply this first function, which is OR, in the second iterator, okay? We don't need to go into details here, but basically this is can be rewritten using the for loop. Say the ID equals 0, and then for W in the word, and do this ID equals ID or this bit 1 shifted ORD. If it's A, then we shift the 0 position. If it is Z, then we shift the 25 to the left. Okay. This is more fancy syntax because it allow us to transform the word using the bit masking. Yeah, we transform the lowercase characters into a big integer, and then we can compare two integers. If the two integers are the same, then we say these two words are similar. Okay, and it's still based on this one. And the time complexity, let's analyze this a little bit. Okay, so this is n, right? On. The space complexity on. This function is w. So on times n, right? And that's it. Look, previous function, the Bruteforce is on squared times n, right? Which method is better?
The one you just said?
Yeah, because look.
Because you always do the best
ON.
one last.
Yeah, ON, yes, of course. I always say the most intuitive is the Bruteforce way, because that's easy to come up with. And we talk about the improvement. Look, this is ON, right? And the ID function is OM, right? So ON times M. The space complexity using the counter. Okay, and let's see. Okay, what have you learned today?
anagram.
not anagram.
And we have similar like letters in them, and you call them similar.
Yeah, we call it similar. Okay. So which method can you explain to me? How many methods we have talked about?
3.
Yes, to be exact, yeah, 3. But the third one is based on the second one, just the ID function, we improve it, okay? 4 apples, picking 2 apples, how many ways?
6.
Yeah, 6 pairs, right? 2, right? So we can brute force. Yeah, we can brute force, and then we check if the 2 words are similar, right? How do we check if 2 words are similar? We just convert it to set, and that's it, right? Because set only stores the unique numbers and do not care how many times they appear, right? Okay, that's it for today. Bye-bye. Bye.
Bye.